So how do we check if all list elements in our list are true in Python? That's what we're going to talk about today. So let's hop right in and start coding. So I want to walk you through 2 different ways that you can check if all the elements in the list are true in Python. And the first method I want to walk through is more of the naive approach. Now, the naive approach will help you kind of more overcome probably some of the gotchas that the more Pythonic approach does, because it kind of has some built-in things that overcome the truthiness and falsiness that Python plays with. And we'll get to that more in a second. So just wait on that. Let's go over the naive approach, and then we'll kind of get into more Pythonic approach and how that deals with Python's truthy and falsy type values. So the naive approach, essentially what you would probably do is, as you can probably guess, is you just loop through the list and check if all the elements are true, right? Now you can do this through list comprehension, or you can do this through probably more just looping through for loops. And I'm just going to show you the very basic naive approach, which is simply just going to say, we're going to probably create a counter. Count is equal to 0. I'm going to say for val in true list. I'm going to say if val is equal to true, then count plus equals 1. And then what we're just going to say, we're going to create a new variable check to say, hey, is everything true? So is all true? And that's going to set equal to the logical Boolean expression of the count. The count variable is equal to the length of our true list. So as you can imagine, what we're going to go through is each index, and we're going to say, hey, is this equal to true? Yep, plus 1. Is this equal to true? Yep, plus 2. All the way to the end, plus 3. And then at the end, we're going to say, hey, the length of our list is 3. The number of elements in that list that we got, the count equaled out to 3. So yes, 3 equals to 3, and therefore all is true. And again, we can test this. We can say print is all true. We can say the count. I'll just do this. I'll make an F string and I'll say count equal to that. And then we'll say length. We'll do another F string and say length of true list is equal to this. And so if we go ahead and we run this, what you'll see is that everything is true. The count is equal to 3 and the length of 3, or the length of our list is equal to 3. So therefore all the elements in the list equal to the value of true, right? Now, there's gotta be an easier way, because what happens if we're dealing with not just values or like other things, like we're going through a big old list and we don't necessarily want to loop through a giant list, right? And what happens if you want to check if everything's in like a double for loop or a nested list, and if all the internal stuff is true, we don't want to loop through multiple things or even a giant thing, right? We want to simplify this. Well, that's where the built-in function or built-in method comes in that we're going to talk about now. So that built-in method is actually the all method. Now I can say is all true and equals to all, and then just pass it the true list. And what this is going to do is, like it says here, it's going to return true if bool of x is true for all values of x in the iterable. So I can pass in an iterable such as our list. I can pass in an iterable as a set, a tuple. It'll check all the values that are true, right? So if I go ahead and do this and then come down here and we'll print this value out, bring this up a little bit, and we go ahead and we'll reset this and rerun. And just like that, you see that, look, they're all true. But here's where things will get a little interesting. So what I'm going to do here is I'm going to say this is more naive approach, and I can't spell, so don't pardon my spelling. Oops. All right, naive approach, and we'll say that this is the more Pythonic approach, right? So again, I rerun this, it's gonna all work, right? We see that true and true. Now here's where we get a little thing. Now there's a thing in Python called truthy values and falsy values. And I put a Python quiz in the community where I asked this kind of question, how do you check if all of it's true? And someone said, hey, well, how does this handle like when the truthy values, right? What is a truthy value? Well, basically a truthy value is anything that would evaluate to true in a Boolean context. Now, what the heck does that mean? Well, if I were to say something like if 1, well, 1 usually equates to true, then do print hello, right? Or if I say print a list that's non-empty, or a set that's non-empty, or a tuple that's not empty, or a dictionary that's not empty, that'll equate out to true, versus a falsy value, which is basically evaluates to false in a Boolean context. So such as things as none, that keyword of none. So I could say if none, now this is a special case, but that'll equate out to false. Or I could say if this is an empty list, or an empty set, or an empty dictionary, or an empty tuple, all those type of things equate out to false, because in their context of like checking their Boolean context, they're either empty, which means there's nothing in there, so that's false, or they have something, which means that equates out to a truthy value, right? Okay, so now with that in mind, right, if we switch this list up to be a non-empty list So true, non-empty list value, and true. Do you think that this will equate out to false? Or do you think it will equate out to true? Well, if we use the truthy logic, this should, given the Boolean context of which this is what this evaluates, the all statement, I believe, and know that this should equate out to true. But what will the naive approach do? So if we go ahead, and I'm gonna just do this, reset, ampersand, ampersand, and rerun the script. This will clear the screen and rerun it all. The naive approach says false. It does not equal to true. Whereas, because when it's going through, it's specifically looking for that Boolean value of true. So when it gets here, yep, that's true. When it gets here, that value does not equal to the true Boolean value, right? And we can say else, and I'm gonna print out the val just to show you. So when we come down here, we see that the val that gets printed out is this val. And it's because that does not specifically equal out to that Boolean value. Now, if I were just to say something like this, if val, and I were to then run this again, you would see that now they both are equal to the same thing. It's because this has a truthy value. So when you compare it to this, it's just true. But when you change it up, and so I'm gonna hit Control Z, and you go and specifically say, does this equal to the Boolean value of true? It's false. So that's why the naive approach right here is saving us, because if we're looking for something that's like this, I can't spell again. If we're looking for something that's like this versus something like this, you run into an issue kind of going with this pythonic expression, because it's going to look for truthy values. Again, if I do something that's like this, 1, then I'm going to say, hey, that is true. If I do something that's this, now this is an empty one, so this would return a falsy kind of equation. If I run this, they're both going to say false, right? And that's because this will equate to false when it's running here, because again, this is returning true if bool, wrapping the bool data type around that value returns true or not. And when you wrap something around an empty list, an empty set, an empty anything, and the special case of the keyword of none, those return false because they're falsy. So that's kind of what it means by truthy and falsy values, right? And so when you want to get all, or when you want to try and get them all, it depends on if you know that you're just dealing with trues and falses and not anything like empty lists, empty sets, or whatever in your list. And you're just dealing with like true and false here. Again, run this. This should equal out to false. Then it's okay to use this all thing, right? It's okay to use a built-in all because it's specifically looking, or it's not necessary. It's okay because you know that you as a programmer essentially know that we're only dealing with these values, and that's what I'm looking for. And then you can use it. But if you have a list that could be a mixed data type list, that's when you need to reevaluate and say, hey, should I go with a for loop? Should I go with some list comprehension, or should I evaluate something else? Because I could be dealing with an issue where I'm looking for all trues and expecting a complete data set of Boolean type and not necessarily one that contains a mixed data set. So I hope that this provides a little bit of value. It just came up in our Python community, or in our community question that I posted on the YouTube channel, and I wanted to bring this to light. I wanted to talk about this because I knew about truthy and falsy stuff. I didn't really I just kind of had known about it, and it's just one of those things you kind of like learn over time. And then when someone asked a question, I was like, oh man, that's a good question or a good ask on this thing, because yeah, if I want, and in the question I said, hey, the easiest way to do it, the answer that I said you should use is this. But I totally spaced that, and I was going with the context that I was thinking we're just looking for these values and not a mixed data type where it could be, Boolean values, list values, string values. But again, if you do have those things, you have to be very careful with this, because if you're looking specifically for that, it could not turn out how you would want, right? So I hope this provides you value. If you have any questions, leave them in the comments below. And until next time, keep on programming.